That melting point can go up to 1700 degrees Celsius. Cast iron, which I will come back, is a special one, that is melting at 1200 degrees Celsius. Let me put a few others that's not relevant now, but we will get to our material classification in more detail. For now, just know that this is our limitation right now, is commonly mild steel and maybe high carbon steel. I might have stainless steel that's also got like a higher temperature, but these are the common ones that we're using. And that's one of the limitations of arc welding. It can only be applied to like a selected group of materials. We are expanding that into a lot more, but right now, these are the three main processes in arc welding. One in gas, three in electricity. But what came out of this is just like I already said, we had like 1.1 submerged, underwater weld. I can also now with this do stainless steel. Nowadays I can do aluminium, aluminum. So I can now start to do quite a number of other materials. I can also now start to listen to this, do bi-metals. Remember when I said that I want to fuse them, melt two materials into one. I want to have the same characteristics of the material. If they are mixed, if there are two different types of material, you're not mixing them into one material. For instance, if I've got like iron and weld that to iron, if it's welded together, the fusion layer here is what? Iron. But if this is like high carbon and that is like iron, low carbon, what is this mix? I don't know. It's not as strong as that, it's not maybe stronger than that one. It's already ready to break. Welding is limited to the same material, but we have special rods now that can do bimetals. Okay, now with this process we have increased our welding technique quite substantially. I'm wrong. Before I get onto this, can I put the fourth one? Can I put the fourth category down there? Sorry. The fourth category is non-arc welding. It's just like electrical short, and that is like, we call it spot welding, seam welding, etc., etc. Spot welding is the common one. Spot welding doesn't use a machine, it does use the same transformer principle, but there are two copper electrodes pressing on material, creating the short, and there's no filler material. This one has got a filler material, this one has got a filler material, that one has got a filler material. Filler material meaning there's a rock or some material that you can fill up. Spot welding, you put the two plates together, thin material, it melts that spot and it melts the two together into one. Seam welding is where you've got like that electrical process like seaming. So sometimes you get material that looks like it's been seamed together. That's called seam welding. Many tins, many holders are seam welded. So that means you've got that seam that's welded. We use that process also when we manufacture steel pipes. Yeah.
When you use like the spot welding on steel pipes.
so you put electrical charges on both sides. When the sides come together, it melts into one. You'll see your pipe has got a seam on it. Okay. Alright, so that means you still need to get that out.
Yes.
So remember, when we are looking at this, also look at pipes. There are many processes that uses this. For instance, if I can now already spot weld two materials. Like in normal contactors, electrical contactors, we've got a copper plate and a stronger tungsten tip on it, and we weld the two and we can fuse it into each other. So that's also a spot welding process. So it's like there's definitely use advantages that's happening. So technically 4 main processes. But in each process, like in gas, with the argon, so now I'm getting mixes in argon and I'm getting that, and I can now, even what we now can do is we can, in this one, put flux, core, arc, welding. Now what this means is, this one uses, the gas metal arc welding, uses a roll wire, solid. This is solid. So if I look at that rod, it's like a solid rod like that, a wire rod from the front. Flux core has taken the gas away in some cases, and then all of a sudden the flux is included inside the wire.
Inside the wire.
Yeah. So that means you come in with your flux and you're coating it with steel around it. So like you're dipping like ice cream in when you're doing like this caramel, you're dipping it in there, when you take it out, the ice cream is inside.
Oh, okay. I get it.
So now the flux is inside, not outside like this. It's inside. It's called flux core welding. I can use it with gas or without gas.
Without gas.
Yeah. Sometimes I use that flux there and I put a little bit of gas around it. You remember this one to melt, I put the argon gas around it so that when it burns, it's like shielded. Right?
Yes.
Now I can do it with the flux and the gas or just with the flux inside. We can also use, like the gas processes, we can also use metal sprays. What that means is we're using a gas like a spray gun. So you put like a powder gas of metal into a powder box, like a spray gun bottle. And you've got the spray gun nozzle electrical that's blowing the electrical spark out. So when you trigger, the air picks up the metal, mix it with the flame, and spray it onto your material. So when we, in some cases, want to put a very strong layer onto like a crankshaft or like a piston or something like that, we use metal sprays. That looks like the starlights we normally use. It's like spraying that, but that metal goes right onto your metal, burns into it, and it's a very thin layer, very high quality.
Okay. So can I ask, like, where does like soldering iron falls under here?
Where does?
Soldering iron.
No, I'm getting to that.
Okay.
It's not a welding process.
Okay. Okay.
So, up to now, this is the end of our known welding experience. We get induction welding, we've got laser welding, we've got a lot of things happening, like TIG welding is now into laser welding. I mean, you can cut down molecule thicknesses. So with a laser welder, for instance, you don't create, you create but not like with oxyacetylene, 3000 degrees Celsius. You're creating like 7000 degrees Celsius. Lasers are normally working between 6 and 7000 degrees Celsius. That means you can take one molecule at a time. Very minute cuts, very precise, very exact. Why are you looking at me like that?
You're saying it produces how much?
7000 degrees Celsius.
67.
Yeah.
Okay.
That's why it's called a laser. And you know the laser story that's going around, you can go through anything. Yes.
Yes.
7000 degrees Celsius can go through anything. So that's why it's not commercial, it's a highly dangerous process. It's becoming more commercial, they are getting it more commercial, but I mean, that's why lasers are known to be extremely dangerous. You know, like this Superman with the laser eyes, you can look at, you know.
Yes, yes.
Yeah.
You just
It's putting that picture in your mind, you say, what's up? So the next question is, what is not welding? Or what is the alternative to welding? Can you see that right now, I need to know a little bit more about material classification. So I can see what options do I have other than welding. So let's first look at material classification. Material classification, we can first divide that into metals and non-metals. Metals we can divide into ferrous and non-ferrous. Ferrous stands for Fe, that's a symbol for iron. So one that contain iron, one that doesn't contain iron. I'm going to like the non-contain, these are like copper, lead, silver, aluminium, etc. Non-materials are glass, ceramics, wool, wood, plastic. Why am I doing this as a basic classification? Because in life, you're not only working with a very limited ferrous metal. Can you see that welding is like one out of the whole group, commonly used. We have now developed for some of the non-ferrous, we can now already, like with aluminium, we can weld it. We can do stainless steel, we can weld that. But we are still limited. But if I've got a stainless steel piece and I need to add aluminum to it, welding cannot do that. So, if I want to do joining techniques, let me just focus. Joining techniques include welding as one of them. Because now I join two materials into one. But how can I join materials? Especially when I'm getting to materials. You remember now, cloth to iron, iron to wood, wood.
yes.
What can I do? How can I join? Just name a few.
You can forge.
Bolt and nuts. Screws. Nails. Glue. Sewing. Just to mention a few. Rivet, one that we often use. And, well, Can you see the limitations of welding? When I'm using welding, I'm limited to mainly ferrous, with a few other exceptions, struggling to combine randomly amongst them, and then I need heat, and I need only limited process that I can apply. But joining techniques like bolts and nuts, you can drill a hole and you can bolt them together. You can rivet them together.
So, in other ways, we can, under training techniques, we can say we have temporary and we have permanent.
Yes. Like when we're gluing, and I'm coming to that, it's like semi-permanent, but it could be like more permanent.
Okay.
When you're making a t-shirt like that, the seams
Okay.
are permanent.
Yes.
You don't want to undo the.
Yes, they are permanent.
They are permanent. Otherwise, you would have used knots. Something else, maybe it's studs or something like that. Joining is relevant to us, of which welding is only one of the processes. But that allows us now to get into like alternatives. Now, I want to add to this soldering, brazing, so what is soldering and brazing now? Soldering does not fuse the two materials. It glues them together. You put heat on that, you melt the lead, two materials separated. You want to braze them, it doesn't fuse them, it doesn't melt the materials, it glues them together.
So, which method do we use on brazing? Like the method that we use.
Well, brazing normally, you can do it, but nowadays but normally it's a gas process.
Okay.
Soldering is even a soldering iron. You just plug it into, or you heat it up with a fire, and you can melt the lead. That's why the melting points of other materials such as tin are very important, because they are melting like, lead is melting at 300 degrees, 360 degrees. Tin is like just over 280. Silver is also in around 200 degrees Celsius. It's far less than mild steel. So when I braze or solder or silver solder, okay, that material, the joining material, will melt long before your base material is ready to melt. Soldering is one of the other techniques of joining. Soldering, brazing, and welding is one. But soldering and brazing are like gluing.
Okay. So, when we using like on the CO2, like we have this.
Now you're back at process number 2.
Yes, process number 2.
Yeah.
We have like we're using like we can use brazing on CO2.
No. Brazing can only be used with gas
With gas.
and a filler rod. It looks like that, but it's just a gas process putting onto two materials.
Okay.
Now it can be copper and aluminium, although it's difficult, but I'll explain that because the heat absorption tempo or rate is different for the different materials. So you're going to like melt the aluminium before the copper is hot. But you can put two copper on each other and you can do it copper to copper soldering. We call it copper to copper welding. It's not welding, it's a soldering process. So that means you stick them together, but you didn't melt the two copper pieces. In industry, when we're doing like plumbing, the copper parts, we solder them together.
Yes, we do solder them. Then
It doesn't mean, but if you want to remove it, you just heat the soldering up and the copper come off without being damaged at all.
okay. So on soldering, we can use like a flex also. Like
Yeah, you get because you need to help the melting of that liquid. So we do have soldering flux. We have to clean it, and you've got like flux that you do when you're doing brazing. You've got brazing flux. That flux is the same flux as this. It's a chemical to assist the melting of your material. And you don't want to mix it. That's normally on top of it. It's like lighter and it's coming at the top. So you will always see that chemical whenever you're using a flux. Whether it's there or whether it's there, the slack, the chemical burnout is always visible.
Okay. So the flux that is being used here is the same.
Chemical compositions are different for different purposes.
Okay.
But the main reason for using flux is to increase the melting process.
So we can call a flux maybe a catalyst.
As a catalyst, yeah.
Okay.
100%. That's like a catalyst, making sure that the flow of that material is supported.
Okay.
Whether it's in the welding process or whether it's in the brazing and soldering process, all the same. And with that, it is aiming. Now we're getting into how to set up the machines, how the techniques are working, and that's each one you have to take one by one. But this is telling you what is the field of welding look like. Mainly one gas process. We can cut or braze or weld. Brazing, we already said that's it's like a gluing process. But we can weld, that means I can get enough heat to melt the two materials. Then I'm going to the electrical process, which is mainly stick, gas, and TIG. Now, how does TIG work? I've got a tungsten rod, tungsten melting at 3,400 degrees. I create electrical short, that means it's a little short there, like a car spark plug.
Okay.
And it doesn't burn away. So it creates that spark and it creates that very focused heat source. And you just put the filler rod in as the puddle grows.
So this way is just to create the spark.
Yeah.
Okay.
So the tungsten is there to get the electrical short, and you sustain it, and then you put the filler rod in. Once you melted your material, you can see the puddle, you just add filler rod to your puddle. Amen. Welding is easy. Welding, when coming to practice, is 90% muscle memory. Let me finish up with that. That means there are strict safety rules related to welding. 5 safety rules to any of this that you will find in all regulations. There are 5 key things that you need to make sure that's always at your availability or in your safety environment. First thing is make sure, okay, let me just, while I'm talking about that, why we call that CO2, because we don't even use CO2 gas, we use argon. So why do we call it CO2? The only reason why we call it CO2, why it became known in this is CO2, because after stick welding, the nice thing is, when stick welding, you burn, and when there's a fire or the heat, it burns up all the oxygen, and you get carbon dioxide. But not enough. That means if you are welding like a lot in a confined space, by tonight you're like dizzy.
Oh, because of the fumes that you...
Because of the fumes.
Okay.
But the nice thing about stick is you have to stop, change again. That like diffuses the carbon dioxide. But with this process, no, I mean that machine can run the whole day. So it burns a lot. So what they discovered when they are like sitting and welding like the whole day, like this afternoon they are like, what's going on?
Okay.
You burned up all the oxygen. And that's why they call it, that's a CO2 machine. It's burning, it's just creating CO2.
So it burns like, it burns the oxygen.
It burns the oxygen and it only leaves you with carbon dioxide.
And you'll be breathing.
And you are breathing in a far higher content of carbon dioxide. That's why in industry we call it the CO2 welding. I mean, that's carbon dioxide welding. I mean, it's like, it's going to kill you.
Oh, okay.
Be aware, it can kill you. Alright, so let me go through the key safety thing. First thing is air. CO2, the reason. So you need to make sure that there's enough air in the environment that you are working. We don't want to have too much of that. Second thing is you need to have light. That means you must be able to see what you're doing. The third thing, there's always a fire risk. That means there must be a fire extinguisher close to you. We're working with heat and flames. You need to have a fire extinguisher. First, air, light, fire. Key three things. Thirdly is your own protection. Eye protection, head protection, body protection. Any of these rays, you don't have the right PPE, you are screwed. You can get arc eyes, you can get serious burn, you can have many things. So like the welding equipment, safety equipment are special, they're fire resistant, they are like very durable. So PPE. And then obviously correct equipment, let's include the equipment with PPE as well. That means the right machinery, the right accessory. Okay. And the last one is workspace. Because when you close down, you protect yourself, you don't want to stumble onto something. Okay. So you need to have a clear workspace. 5 things. Let me go through it again. Air, light, fire protection, like fire extinguisher, PPE and equipment, the right equipment and the right PPE. And the last one is safe working space. Then you can start to practice, and welding is a muscle memory process. Welding is a muscle memory process. You're going to the gym, I can see that. So why are you going to the gym? There's certain muscle memory. You can now do a number of the jerks that you want to do with that weight. Yes. And eventually, if you want to change, if you now have to go and run 100 meters, you're like, I thought I'm fit, you know, like, yes. What the hell is going on? I mean, like, I'm dead tired. Yes. And the reason why is you don't have the muscle memory of an athlete. Yes. You've got the muscle memory of a gym person. Yes. So, welding is the same. Welding is muscle memory. To weld the same rod, have the same distance, is all muscle memory.
Like being able to weld, they say to weld like the whole day with the same speed. Like
with the same speed, same quality, same. Okay. With that, I want to conclude with the last part on welding and just explain people in welding. The first person, we can get operators. Welding operators are people that's in charge of a welding machine. Some are so automated that, like the robotics, like the spot welding, they're just operating. They're not welding, they're not even moving it. There's no muscle memory, it's programmed. So I can't call that guy a spot welder. He's an operator. So we've got welding processes that are highly mechanized. If I'm building a ship, seldom you'll find welders sitting there welding every inch. You've got machines, you set them up, you start there and it welds your material. Cutting the same, so that's operators. Number 2 is coders. welders. And number 3, let's call it red seal. That's the trade. Let me explain what's the difference between a coded welder and a red seal. Operator, you already now know, is the person that operates. A coded welder, many equipment like a gas bottle, like safety equipment on a car, on your safety belt, maybe in the frame of the car. If that thing breaks, people will be killed. So what we've done is we have trained people to do only that type of weld. So a coded welder is company specific, product specific, technique specific. That means I can produce 1,000 of an item at the welding procedure. We call it a welding procedure. That means there's a procedure, say step 1 do this, step 1 do that, step 3 measure that, set the machine like that, step 4 keep it like that. And you test it and you certify that, you become a coded welder. You weld a specific code. Code is a prescribed procedure on a product.
So on coded welder we can say it's someone like
He is extremely good. I can't swear now. You see, you like this.
okay,
He's extremely good in doing only that. And you ask him to weld your gate at home with stick welding, he's screwed.
oh, like that person specializes in that criteria.
Only CO2, only that weld, only that material. He doesn't know much. Yesterday I trained a group. The one was, he's a coded welder. He's coded to do certain welds for conveyor belts. When we started to do stick and tick, he was gone. Gone meaning like, he was supposed to be bragging. He couldn't.
Because there's this pastor from Pembo yesterday while I was busy there at Welding. She came and asked me to, like, she wanted to do some field labs there. She was a problem. It was so difficult for her. Then I asked her, why are you actually doing that side of thing? She said, I'm welding.
Yeah.
With what?
She's a coded welder.
Now I understand why.
So that means she never touches the stick. I mean, when she gets the stick in the hand, she's got no muscle memory, it's like, you ask her to set that machine up, she's screwed. She doesn't know where to start. But when they're on that machine, they're brilliant. I mean, once they're on their product, on their machine, on their process.
Yes, she showed me like a few pictures of her what is doing.
Yeah. And that's good.
Yes, it's good.
Yeah. She's a coded welder.
Okay.
A coded welder is limited in the scope of all techniques. Where you're a tradesman, and the more I trade, you need to be able to do all the techniques, the variety of techniques. You're not a master in any one of them, but you can do any one of them, depending what's available.
Okay, so is this whereby the word comes from, like saying a person who is a jack of all trades, then master of mind, like it comes from there because of a person that who has to know like everything.
I'm like that. I'm not saying that I'm a coded TIG welder. You see coded TIG welders, I can tell you, I've trained some coded TIG welders. I've got no chance against them. No chance. Why? When they're getting to, just to help you understand TIG welding, that one of our companies, they make bellows. A bellow is like a concertina, you know, these things that are flexible, like exhaust that is like flexible. Come on, have a look here and see what's a bellow. Don't tell me you don't know what's a bellow, man. Don't know. Let me show you what's a bellow. If you see a bellow, then you will know. Images. Can you see there's bellows? Oh, can you see the bellows? Can you see that's a bellow? That's a bellow. There's one. Wherever you need a flexible thing in between. Yeah. They weld that under electron microscope because they're doing that for the medical trade. They're welding under electron microscope. I mean, with your eye you can't see what they're doing.
Yes, yeah.
But when they're in the electron microscope and you see like welding, keep welding, that little thin material, somebody's life is going to depend on that diaphragm that you're making.
Okay.
Oh,
It sounds so complex.
very complex, but that's not common. So the common thing is that, like as I said, TIG welding and all that, it's growing. But when you are a red seal, you should be able to like get the basic work done with stick, basic work done with CO2, gas welding, and maybe TIG welding.
Okay.
The advanced processes like metal spraying and things like that, if it's so seldom that you use that in repair main shops, maintenance shops that you might get, or in like specialized area. For instance, there was one of our companies that are manufacturing earth moving equipment. They had a welding operator process where they do like immersed flux core welding. So the flux is like a powder and the rod is coming under so the flux is separately poured onto the weld. So the electrical shortages, they didn't even know that. When I visited them, I said, so how many processes? No, we don't know. We're using like CO2.
Okay.
So when I walked through the process there, it's like, no, what about this process? I said, no, it's the operators. It's just a machine. No, it's not a machine, it's a welding machine.
It's a welding machine. Okay.
I'll show you pictures of that as well later on.
Okay.
So now you can stop your video and you can ask your questions.